Let's start by talking about the exoplanet itself. It wasn't discovered by the James Webb, all right. In fact, that's a very important point. Can the James Webb discover exoplanets? Well, it can. But its main job is not to discover exoplanets, but rather to characterize the atmosphere primarily of exoplanets that have already been discovered, and for which we need a very good characterization. That's what happened with this exoplanet in this recent release by the great James Webb. Back in 2015 during the K2 mission, which for those who don't know, if you're new here, there was a very important mission called Kepler, one of the great discoverers of exoplanets. The Kepler mission had a problem later on, and when it had that problem it was dubbed the K2 mission. So in 2015, using data with the K2 mission still in operation, astronomers discovered a planet orbiting the star K2's 18. This discovery was made using the transit technique. Why? Because both the Kepler mission and the K2 mission were based, well, they were because they don't exist anymore, on the transit technique. What does that mean? To discover an exoplanet, it needs to pass in front of the star. This creates a dip in the star's light curve, and then you can discover the exoplanet. The exoplanet discovered in 2015 was named K2-18b. It's a planet that is 2.6 times the size of Earth and is located 120 light-years away from Earth. It orbits its star, K2-18, which by the way is considered a cool dwarf star, and it's in the habitable zone. But it's a planet that has 8.6 times the mass of Earth. With the mass and all and the size, researchers classify exoplanets. And K2-18b has a very interesting, very peculiar classification. It is characterized as a sub-Neptunian, which means it's slightly smaller than Earth but smaller than Neptune. This is quite complicated for us to understand because in the solar system we don't have this class of exoplanet. We have Earth, then we have Neptune, and so on, so we don't have a sub-Neptunian. That's why this discovery is very interesting, not because of what people are saying, but for this reason. Oh, another very cool thing. For those who don't know, this type of exoplanet, sub-Neptunian, is the most common type of planet in our galaxy. These are the most frequent planets of this size, so all of this makes the James Webb's discovery very interesting. With all these characteristics, size, mass, orbiting a specific type of star, and being relatively close, 120 light-years in astronomy, that's very close. The Hubble had already studied this exoplanet, so the researchers said, let's point the James Webb at it, at K2-18b, and it became a prime target for the James Webb, which only studies an exoplanet when it's in transit. So what's the goal of the James Webb in this whole story? When the planet passes in front of its star, the star's light passes through the planet's atmosphere. The planet's atmosphere is composed of different gases. When this happens with the atmosphere, it's detected here by an observer, by a telescope, by a spectrometer, by whatever it may be. You then have it all divided. You have a spectrum. You can create what we call the spectrum of an exoplanet's atmosphere. Why is this relevant? Because it's through the spectrum that we can identify what types of elements are in the composition of that exoplanet. And here comes something really interesting. When you characterize a planet's atmosphere, you can learn a bit about its history. That's right. Depending on what's in the atmosphere, it relates to what came from the planet's surface and ended up in the atmosphere. So when you have a very good characterization of a planet's atmosphere, you can understand its geological history, or at least a good part of it. So they pointed the James Webb at it, initially using the NIRCam. They haven't used the instruments yet, like the MIRI, which I'll talk about in a bit, but they went there and took the spectrum. And the spectrum has some very interesting things in it, in the spectrum of K2-18b. First, it has methane and carbon dioxide. Additionally, it has a bit of ammonia, and it has a molecule, as I mentioned, that is related to life here on Earth, which is dimethyl sulfide, the famous DMS. So, here we go. The interesting thing about methane and carbon dioxide is that they are greenhouse gases. Because of the presence of these gases in the atmosphere, astronomers, even without seeing the planet, deduce that it's a Hycean planet. And then comes a name that many of you have probably never heard of, Hycean. Hycean is a type of planet that has a vast ocean, basically entirely covered in water, but it has an atmosphere with hydrogen, hence the high in Hycean. So K218b is a Hycean world. And this is related to everything studied in the atmosphere. As I mentioned, all these characteristics point to it having a large ocean. As for the other molecule, dimethyl sulfide, it's much more interesting because here on Earth, it's produced by phytoplankton you see in marine environments. In other words, it's produced by life. However, of all the detections in the spectrum, carbon dioxide is very well defined, methane is very well defined, ammonia is very well defined, but DMS isn't. In other words, it could be DMS, it could be other molecules there, so more studies will be needed to figure all of this out. And here comes the big question. Did the James Webb discover life? No, it didn't discover life. Does this planet have life? We don't know, but most likely it doesn't, even though it's in the habitable zone. Being in the habitable zone doesn't mean everything in it has life. But this planet has a serious problem regarding life. Normally, planets with large oceans have water that's too warm for the development of life, so it's possible that there's no life on this exoplanet. All of these results I mentioned, the spectrum and all, came from just 2 observations made by the James Webb. Of course, the James Webb will do much more. It will use the MIRI soon, which is a mid-infrared instrument. And it might be able to further characterize the atmosphere of this exoplanet. Again, if it's not life, it's still important. One of the important aspects is that it shows that the James Webb is capable of studying planets or exoplanets in the habitable zone. So it's proven that this is possible, and the James Webb can conduct this type of study. That's already very interesting. Another thing is studying an ocean world so that we can understand it better, to get a better idea of what these vast worlds in the galaxy are like. So, as I mentioned, the team of astronomers is yet to use the MIRI and will continue to study. This is an exoplanet that generates a lot of interest. So, to recap, the exoplanet was not discovered by the James Webb. It was discovered back in 2015 by NASA's TESS mission. The James Webb was simply used to better characterize the atmosphere of this exoplanet. Although the Hubble had already studied this exoplanet, it couldn't provide a very good characterization of the atmosphere. The James Webb, with its instruments, can do that. With this improved atmosphere characterization, you can learn a bit of this exoplanet's history, but it's still a very interesting discovery. So folks, that's it. The James Webb, one of its objectives is to find life, to find biosignatures. That's why studying these gases is so important. And we'll wait to see what happens in the future. Do you have any ideas? Let's follow along. Leave your thoughts in the comments if the James Webb will or won't find life out there in the universe. Alright, so folks, this was the video I wanted to bring to the channel for you now. I hope you liked it. If you did, you know what to do. Never forget the YouTubistic package. Share, favourite, subscribe to the channel if you're not already subscribed. Leave in the comments whatever you want to know.